First section in this chapter, we talked about some of the basic definitions of probability. We talked about an experiment, we talked about outcomes, we talked about sample space, and we talked about events and what that meant. But we didn't actually calculate any probabilities whatsoever. So today we're going to start calculating things like this. Okay, the probability of an event is a measure of the likelihood that an event will occur. It is a number between 0 and 1. Okay, probability is measured not in terms of percentages, although it's easy to convert a probability to a percent, but it's a number between 0 and 1. And also notice that we talk about the likelihood of an event occurring, not an outcome. So we can take a few outcomes and put them together in an event and then measure that. Okay, so 0, a probability of 0 means event will not occur. A probability of 1 means the event will occur. And a probability of 0.5 means the event will occur half the time. So you're probably used to thinking about percentages, right? But you just slide the decimal point over 2. That's the only difference here. Oh. Okay. So, example. The probability it will rain tomorrow. We could look at the probability it will rain tomorrow, and we could say that could be 0.3. Okay, 3 times out of 10 it will rain tomorrow. That necessarily means then the probability it will not rain tomorrow would be 0.7. Because it will either rain or not rain, right? Those are the only two possible outcomes or options. So it will rain or it won't rain. So together that must equal certainty. Okay? I can be certain with probability of 1 that it will rain tomorrow or it will not rain tomorrow. Okay, those are mutually exclusive and they exhaust all possibilities, so the sum is 1 there. Okay, now let's look at another example. Let's toss a coin 2 times. The sample space, I'm going to abbreviate that SS unwisely, looks like this. Heads, 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 tails, tails, heads, tails, tails. Those are all the possible outcomes. That's the entire sample space of what can occur for tossing a coin 2 times. And each of these is, of course, equally likely. So that means the probability of getting heads, heads is equal to exactly a quarter. A quarter of the time you should get heads twice in a row. We could also look at a more complicated event, like the probability that we have at least 1 head. That would be, okay, that one works, that one works, that one works. So it would be probability 3/4. Okay, if we put these in decimal, this would be 0.25, and this, of course, would be 0.75. Okay. So that's another situation where we can easily assign the probabilities to what's going on. Now let's look at another example. Let's roll 2 6-sided dice and record the sum. So we'll make a table for this. This is die 1, die 2. We can get 1, 2, 3, 4, 5, or 6 from die 1. We can get 1, 2, 3, 4, 5, 6, possibly for die 2. Those are our possibilities, right? And now we record the sum of these numbers in the table. So 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. Okay, so there's all of the possibilities, right? And now we can say what is the probability of a sum of 7. Well, we look at this table. We note the 7s occur along this diagonal here. And there are 6 of them. And there are a total of 36 total sum outcomes that we see in this table. So this would be 6 over 36, or 1/6 of the time. Right? Is that about 17%, I think. I think it's 0.16 repeating. Okay, so 1/6 of the time you will get a 7 when you roll 2 dice. Okay, and then we could say, what's the probability of a sum of at least 8? Well, then we circle, okay, what is the at least 8 is this portion. And I count how many things are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This would be 15 over 36. Okay, this is reducible, I believe, to 5/12. Okay, so not quite 1/2, a little less than 1/2. Any questions about these examples? Okay. All right. Another definition. This one's not very important, but an event that consists of a single outcome is called an elementary event. An elementary event. An example of an elementary event is this one right here. Since the only outcome we're recording is the sum of the dice. We're not thinking of different ways to get a 7. We're only recording the sum of the dice as the outcome. Then a sum of 7 is an elementary event if we're only recording the sums. Okay. So here is what they call the addition principle. So if an event E equals, say, outcomes S, T, U, Z, and S, T, U, all the way to Z are single outcomes, then the probability of the event E is the sum of the probabilities of each single outcome. So sometimes it will be easy to see how to break down an event into different single outcomes. And then if we can compute the probability of each of those single outcomes, then we can simply sum those up to get the probability of the event. Sometimes, however, we will see events will be hard to write like this, and so we'll need some other way of figuring out how to find the probability. So here's an example we'll do here. Considering all 3-child families, find the probability that the family will have 3 girls. Considering all 3-child families, find the probability that the family will have 3 girls. Okay, so we can write the sample space here. We could have boy, 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 girl, boy, girl, boy, girl, boy, boy. Okay, that exhausts the all boy and single girl possibilities. Then we have girl, girl, boy, girl, boy, girl, boy, girl, girl. That exhausts the 2 girl, 1 boy possibilities, and then finally we have girl, girl, girl. And my pencil doesn't like to work on the far right edge. Okay, so we should have 8 things in this sample space because 2 cubed is 8. 1, 2, 3, 4, 5, 6, 7, 8. And how many of these outcomes have 3 girls? There's only 1. So the probability of girl, girl, girl is 1/8. 1/8, 12.5%. So probability of 0.125. So given that a family has 3 children, what is the probability that the family will have 3 girls? It's 0.125. Yes, Kayla.
So, like, what exactly does it mean to be a single outcome? Like, what would be the opposite of single outcome?
If I want to say probability of at least 2 girls. That's not an event that has that's not an elementary event because there are several outcomes which lead to that. This outcome, this outcome, this outcome, and the last one. Yeah. But I can break that into different single outcomes. That's the probability of girl, girl, boy, girl, boy, girl, boy, girl, girl, and girl, girl, girl. And then the sum of those 4 probabilities will be what we have here. And so that'll be the sum of those, each of those which has 1/8. So that'd be 4/8 or 1/2. So probability of having at least 2 girls is 1/2. Okay. Now, do we have any degenerate gamblers here in the classroom? Oh, sorry. Responsible gamblers. Any responsible gamblers? Yeah, okay. So odds. You've probably heard of odds. Things like 3-to-1 odds. So the book wants to talk a little bit about how you go from probability to odds. What does 3-to-1 mean in terms of probability, right? And if you're a decent gambler, you probably know this stuff already, right? So 3-to-1 odds equals what probability? Well, the way you convert A to B odds into probability is A over A plus B. So that means 3-to-1 odds converts to, okay, I put the 3 on the top and then 3 plus 1 on the bottom. So this is 3/4 or 0.75. So 3-to-1 odds is the same thing as 0.75 probability. Okay. 3-to-2 odds is the same thing as 3 over 3 plus 2, or 3/5, or 0.60 probability. Okay. So 3 to 2 odds is not as good as 3 to 1 odds, right? Okay, now the question is how to go the other way. From probability to odds. This is a little more difficult. If the probability of an event is equal to P, then you write P over P minus 1 and then try to find whole numbers to make this work. Let's do some examples, right? Let's do the probability of an event equals 0.60. Right? We've seen that already. So if I do what it tells me, P over P minus 1, that's 0.60 divided by 0.60 minus 1. So this is of course 3/5 divided by 3/5 minus 1. Oh, this should be 1 minus P, not P minus 1. I'm sorry. That doesn't... I've got to erase this here. It makes a lot more sense. 1 minus P, 1 minus 3/5. So it's 2/5. So here we get 3 over 2, and that means 3 to 2 odds. Okay. The trouble can sometimes be getting this to look like a whole number over a whole number, right? You might have to monkey with it a little bit in order to get it as a whole number over a whole number if it's not a nice fraction already. Another example, if the probability of an event is 0.9, then we'd have 0.9 divided by 1 minus 0.9, so that's 0.9 over 0.1, which is 9. So this would be 9 to 1 odds. Like I said, unless you enjoy gambling, this is not that useful, right? I don't know, maybe. Well, you know, if you're going to be in business, even if you don't enjoy gambling, everyone does. So you gotta talk the talk, right? So it seems reasonable that you need to learn something like this. Okay. So let me write down the problems to work on today in class. Make sure you're able to do these sorts of things. Number 17 and number 21. And then the homework, which is due Wednesday, will be 6, 8, 14, 28, 30, 40, 42, 46, and 52. And I'll leave the book open here.